Lesson 2.3 is on subtracting rational numbers. All right. Lesson 2.3 is very similar to lesson 2.2. The only difference is we're going to see a lot more negative or minus signs in problems today, but we're still following our same sign, sum, different sign, difference rules. And to figure out if our answer is positive or negative, we're still asking ourselves which of the two numbers that I'm working with are farther from zero. Okay. What we learned yesterday, or not yesterday, but last lesson, is that we have to have a common denominator when we are adding or subtracting fractions. Okay. So in this first example, we already have a common denominator, so that's going to be nice because it's going to save us a step. Now we want to get both sides to look like a fraction or improper fraction. I don't like to really work with mixed numbers here. I like to kind of convert that into a improper fraction, okay? So I can't do anything with this 6/10 yet, so I'm just going to bring it straight down. All right. Now, when we convert mixed numbers to improper fractions, we multiply the denominator times the whole number. So 10 times 1 is 10. And then we take that number and add it to 3. So 10 plus 3 is 13. And our denominator stays the same. Now, we have common denominators, so we can combine our numerators. Right here I have 6 minus 13. Okay, our signs are different, so we subtract. And remember, we always put the higher absolute number on top, so we really take 13 minus 6, and we're going to get 7. 13 is farther from 0. 13 has a minus or negative sign with it, so negative 7/10. All right, moving on. Like I said last time, both sides we want to get them to look like a fraction or improper fraction. Here I have a mixed number, so we're going to want to convert that to an improper fraction. But first, something that sticks out to me, I have two minuses back to back. So when we see that, we karate chop, make them both positive. So I already have those signs correct. Now we need to convert this to an improper fraction. 7 times 4, 28. 28 plus 1, 29 over denominator stays the same, and that fraction still stays a negative. Plus 6/7. Same thing here, it's a little bit nicer because our denominators are already the same and we don't need to convert to the common denominator. So we're all ready to combine our numerators, looking at our signs. Signs are different, so we subtract those two numbers. 29 minus 6 is 23. We ask ourselves which one's farther from 0, which one has a greater absolute value. 29 does. 29 has that minus or negative sign. And I'm going to be okay with just leaving them as improper fractions for this lesson. I'm not going to ask you to convert this back to a mixed number just yet, okay? So negative 23 over 7 will work, okay? All right, moving on. Now here, I notice my denominators are not the same, so we are going to have to convert them. But first, like we've said in the last two examples, we want each side to look like a fraction or improper fraction. So I need to convert this negative 3 1/3. Once again, we multiply denominator times whole number. 3 times 3 is 9, plus 1 is 10, and that fraction is a negative still, minus 5/6. Now, 3 and 6, we need to find a common denominator. What's the first multiple they have? So if I were to list my multiples of 3, 3, 6, 9, 12, 6, 12, 18, 24. Okay, if I already have a match, okay, if they both have the same number in their multiples, all right, that's the smallest number, that's their least common multiple, and that's what we want to use. The first number that they both had was a 6, so we're going to use 6 for their common denominator. So I'm going to write two new fractions underneath these fractions that are equivalent, all right, to this fraction. I need to write a fraction down here that's equivalent to this fraction, and a fraction down here that's equivalent to this fraction. But these fractions are going to look a little bit different. They're going to have a denominator of both having a 6 because we know that they have an LCM of 6. I'm going to make sure I have my signs stay the same. Now, we ask ourselves, how did I get from this old denominator to this new denominator? What did I take 3 times to get 6? Well, that answer is 2. okay? So what we're doing is we're taking both of these numbers times 2 to get my new fraction. We already took 2 times 3 to get 6, so now we need to take 2 times 10 and get 20. All right, and once again, this was a negative fraction, so this has to stay a negative. And we're asking ourselves, what did I multiply this 6 by to get this 6? Well, we took that times 1. So if we take 6 times 1, we also need to take 5 times 1, which is 5. So that one really didn't change. Now I have a common denominator. Now we can combine our numerators. Here our signs are the same. They both have a minus sign in front of the number. So signs are the same. We add. And 20 is farther from 0. So negative 25/6. Okay, like I said, we'll just leave that as an improper fraction for right now. All right, decimals. Okay, remember, we always add or subtract decimals with one on top of the other. We gotta stack them up, and we always put the greater absolute value or the number that's farther from 0 on top. 8 has a greater absolute value. So over to the side, showing my work, I'm writing 8 4/10 and 6 7/10. And remember, we have to line those decimals up. They gotta be stacked right on top of each other. Signs are the same. That tells me to add those numbers. We have to always pay attention to our signs. So adding those numbers because I have a minus sign above each of my decimals. So 7 plus 4 is 11. Carry my 1. 8 plus 6 is 14. Plus 1 is 15. And then bring my decimal straight down. And then we got to ask ourselves which one was farther from 0. Well, 8 had a greater absolute value, so 8 was farther from 0. 8 is negative, so answer is negative 15 1/10. All right, last example. Okay, 12 8/10 minus 21 6/10. Signs are different, so we subtract. And remember, we have to stack the decimals one on top of the other, and the absolute value that is greater has to go on top. We cannot put 12 8/10 on top in this case because 21 6/10 is farther from 0, so we have to put that greater absolute value on top when we are stacking our decimals up. I got my decimals lined up. Now, when it's set up like this, we cannot take 6 minus 8. Okay, there's not enough of 6 to subtract 8 from, so we need to borrow. I'm going to borrow 1 from that 1 and make it a 0, and now I'm going to replace that 6, put a 1 in front of it that I borrowed, and make it a 16. 16 minus 8 is 8. Bring the decimal straight down. Once again, I can't take 0 minus 2. I don't have enough of 0 to take 2 from, so I need to borrow again. And now I'm going to make this 2 become a 1. I need to put a 1 in front of that 0 to make it a 10. Now we can go 10 minus 2 is 8. 1 minus 1 is 0. So 8.8 or 8 8/10, but we have to ask ourselves which one of those numbers was farther from 0. Negative. The 21.6 or 21 6/10 was farther from 0. It had a negative above it, so our answer is negative. All right, homework, page 62 and 63, 2 through 22 even, 31 through 35.